If you've been using Substance Designer by connecting all of its built-in nodes together and then exporting those maps into your 3D software package, that's great. That's what we've been doing on this channel so far. But what if I told you you're only using half the power of this program? Half the power that Substance Designer has to offer. In this video, we're going to dive into what substances are and how you can customize your textures using parameters and functions. To demonstrate this functionality today, we're going to create a picture frame utility substance that lets you easily build frames for your interior design renders. You can choose the picture, adjust the frame and photo size, and customize all of this right within Cinema 4D or your 3D software, all without exporting any new maps. Now, we've got a lot to cover, so let's get started. Think of a substance as a little program. Like any program, it requires you to input something and then get an output. The output in this case is a texture. All of the textures that we've created so far on this channel have been map-based, meaning that we've been exporting images that supply all of our height, roughness, normal, and base color information. A substance supplies all of those maps in one file and then allows you to use parameters to customize your materials on the fly using your 3D package. Here's our example that we're going to create today.
So I'm in Cinema 4D here, and I just want to show off a very simple looking demo of what we're going to be creating today. So we're going to create this utility node here where we can make these picture frames. And I just want to show how easy it was to adjust these parameters and implement them into a workflow using any kind of 3D application that supports substance files. Initially, what we could do is we could model a frame and then apply a texture and then do that for all of our frames. But really, to make it a lot easier, you can use some of the parameters that we're going to create to customize this texture on the fly using the power of a substance file. So to import this texture, all you have to do is go to Pipeline and then Substance Engine. We're going to load Substance, and I'm just going to load this picture frame utility and hit No, and I want to copy it into the source file. And here we go. We've got our Substance Asset Manager. We've got our new texture here, and I'm just going to double click this and name this left frame. And you can see that Cinema 4D, in this case, has created its own texture that references these maps. So I'm just going to drag this in and drop it on our plane. And you can see our frames here now. Now, if I click on our left frame substance, you can see we've got this photo input, and we've got our frame size and photo size. So I'm going to choose a photo here. This one will do. No, I don't want to create a copy of the project location. And you can see it pops in right there. We could change the frame size just right on the fly here just by dragging this slider, and you can see what happens in the viewport there. And then we can also change the photo size to match so we can fit more of the photo in there. And if I just quickly hit render here, I'm just using standard renderer just to quickly get through this so that we can get into Substance Designer. You can see we've got our displacement and our metallic textures and everything going on here. And this is how you can quickly adjust these parameters on the fly using a substance file. All right, let's dive into Substance Designer and make our own picture frame utility substance. All right, so let's create a new graph, new substance. I'm going to use the PBR metallic roughness template, and I'm going to call this picture frame utility. And let's go with 2K and 16 bits per channel and hit OK. So I'm using the latest version of Substance Designer at the time of recording, which is 2020.1.2. I just upgraded after not doing so for quite some time. And the physically based metal roughness template has changed a little from having just outputs to a couple setup nodes. Now, normally I would add a base material node and use that, but today I'm going to stick with blending everything with our final outputs as we go along. So just make sure under Scene you have rounded cube selected. Okay, so to get started, let's create a shape node. And we're going to set this shape to pyramid. And now I'm going to create a blend node. And I'm going to hook up this blend node to all of our outputs so that while we're working, we can see what's going on in our 3D view. So we're going to connect the shape to the foreground of our blend. And then we're going to connect the output of our blend to our normal, as well as our height output. So I'm going to delete this placeholder here. We connected it to the normal node, which then converts it into a normal map. But here we connected it to our height output directly. And then to set up our outputs while we're working, I'm going to delete this uniform color connected to the ambient occlusion node and add our own ambient occlusion, connect that to the output, and then connect this blend to our AO. Now we want to create the detailed shape of our frame. So let's make some room here. I'm going to add a curve node. Now, this is the node that does all of our magic. So here's an example of what we're about to do. Imagine we had a gradient going from black to white in a linear fashion across a plane of geometry. The curve node allows us to modify the interpolation of that gradient and remap it in any way that we choose. So if I want the black to be white, I can just choose to remap it by double-clicking to create a point and dragging it upwards towards white. Same with the white. I can double-click to make a point and drag it down towards the black. So you can see that I've inverted our gradient. The fun part happens when you create points along this curve and remap the values using those points. You can then set this gradient to our height map. So I've got a little bit of a demo scene here, so you don't need to follow along or create any of these nodes. We'll get back to that in a second. But if I edit this curve node now, and I pick a point here and drag it up, you can see that we're modifying the height. And I can add another point. I can change these handles here to make it sharper, adjust the Bezier curve here. Maybe add this little detail, make it go down here. And if you give yourself a little more room, you have some tools here to adjust your pins. So this one makes it a straight line. You can also make one of these handles sharp. So you can see that this curve matches the curve that's going along here. And you can see what's going on in our 2D view as well. So we can really customize what's going on with our height and create really cool looking fine detail with just a curve node. Now, let's apply this to our pyramid shape node. So I'm back in our graph and I've got my curve node selected here, connected to my pyramid shape. And I'm just going to start creating the base of our frame here. And this is the part I find the most fun in this whole process. It's really cool what you can do. You can see what's going on here in the 3D view. Let's make this a little bit bigger. Really customize what kind of frame you're making here. And you want to take the white part and make sure that you have sort of like a flat interior where the picture's going to go. So you want this part to be flat because that's where the photo is going to be. So I'm just going to play around a little bit, add some points. And try to come up with a shape that I like. Great, so I've cleaned up my screen a little bit, and I also have a frame that I think I'm happy with. You can see what my curve is looking like to create this kind of a shape. And to see this a little bit better, I'm going to go to my materials, edit, and I have it on the physically based metal roughness tessellation shader. And if I go to edit, I can increase my scale here. And I have my tessellation factor here up to 16, but if I increase my scale up to something like 8, you can see in our 3D view a bit more of the definition of the frame that we just created. So next up, I'm going to add a histogram scan node in between our shape and our curve nodes. And if I bring up the position, notice how we can change the size of our frame's width and height, as well as the thickness of our frame with just one slider. But if we slide too far to the left, our frame gets very tiny and eventually disappears. To prevent that from happening, we're going to have to limit the range of values that this slider can go to. And to do that, we need to talk about parameters.
Parameters are what give Substance Designer its incredible power. By exposing them from a node to a graph level status, we can customize them when we use this substance in other 3D packages. We can create our own custom user interface to tweak our texture's properties and customize our texture on the fly. Let's expose our first parameter now.
So if we double click on our histogram scan, we go to the position parameter here. If you go to the right, you see this little graph icon. If you click on that, go to expose. And now we need to give this input a name. So let's go down to new. And I'm going to call it frame underscore size. It has to be connected. It can't have any spaces in it. So I have an underscore there. Hit OK and OK. Now, if I double click anywhere on our graph, you're going to bring up our graph's input parameters. So if I twiddle down frame size here, this is the input that we just created by exposing it from our histogram scan. You can see we have our identifier frame size. It's a float, and it's going to be a slider. So let's change the label. I'm going to call it frame size, and this can have spaces, and this is what the user is going to see when they access this property. So now if I bring this down, this default value, you can still see that we're having the same problem. And in fact, now we're having an issue on the other side as well, where it's just becoming too white and it's getting blown out. We could choose a min and max option here, but people like to stick with values they can work with, usually like a percentage or from 0 to 1. So how can we remap this slider to use values that we are comfortable with? Well, first, we need to figure out what those values are. So let's figure out how small we'd like our frame to be at a minimum. I'm thinking somewhere around 0.35 looks good. And then on the opposite end, let's figure out the maximum value this slider should go to. Something like, 0.8 is good. Okay, so we have our values. Now let's click on the histogram scan node, go to the position parameter, and again, we're going to click on this sort of graph looking thing, and just a single click is okay on the icon, and you can see we come into this function graph. Now, every time we adjust the histogram scan's position parameter, it has to go through this function graph, and right now, you can see it's currently being driven by our frame size parameter that we created at the graph level. Let's alter this function graph so that it does what we want it to do. We're going to start off with a clear graph. So I'm actually going to select this and delete it. We need to bring in some numbers or variables so that we can start messing around with them and altering them in the way we choose. To get our variables, I'm going to hit spacebar and type in get float because our frame size is a float. So I'm going to hit enter and we have this get float. And now we need to choose which variable or parameter we've set up from before at our graph level. So I'm going to choose frame size. And that's exactly what we had before, but I just wanted to show you how you could get it yourself. Next up, we're going to add a couple constants. Now, constants are numbers that aren't going to change. They're constant. So let's hit spacebar and type in float. This is different from get float. It's just float. Hit enter. And I'm going to add in our minimum and maximum values. And if you can't remember what they were, they might be different depending on your graph. I've made a little sticky note here. So our minimum float is going to be 0.35. So we'll click on it and then 0.35. Then I'm going to copy and paste. And our maximum is going to be 0.8. And for illustrative purposes, I'm just going to have our minimum at the top, our maximum in the middle, and our frame size variable on the bottom. Next, we need to add a lerp node. So if you type in lerp, lerp, hit enter. Now, what in the world is a lerp? Well, lerp stands for linear interpolation. This node maps our 0 to 1 range of our slider at our graph view to our minimum and maximum values. So the user only needs to think about setting our frame size parameter to something easier to comprehend, like a percentage. When we drag our slider from left to right, from our point of view, it will look like we're working in a range from 0 to 1 or with a percentage. But in reality, Substance Designer is converting that range between our minimum and maximum values. So the way this node works is our top input, this A here, is going to be our minimum value. So we're going to hook up our minimum 0.35 there. Likewise, B, the second value, is going to be our maximum. And finally, the last input here, X, is what is going to drive this interpolation. And that's going to be our frame size float variable that we set up in our parameters at our graph level. So now your graph should look like this. But we're not quite done yet. Functions need an output. We have to tell Substance Designer what value to choose as our histogram scan's position parameter. So because our function's expected output type is a float1, and luckily, so is our lerp, let's choose it as our output for our function. So I'm going to right-click on the lerp and choose Set as Output Node. You'll see some things happen in our 3D and 2D views. Let's check out what's going on. To get back to our graph, you can see we have this little breadcrumb trail here. I'm going to click on our graph. You can always get back to the function by clicking here. And I'm going to double click anywhere in our graph background here. And we're going to get back to our input parameters and frame size. And if I click on this preview tab, this is what we're going to see when we're in our 3D application adjusting our substance file. So if I drag this frame size down, you'll see our minimum value now only goes to here, and it doesn't disappear. Same with our maximum value. It doesn't wash out, and we have our frame. And Substance Designer is linearly interpolating between those two maximum values, but making it really easy for us to adjust our parameters based on a percentage. Up next, we need to add a color input, so type in input color. This is going to be the photo that we put in our picture frame. When we publish this graph as a substance file, our 3D applications will be able to see this input and let us choose what image we'd like to place into our frame. So double click on the input and go to the identifier and call it photo underscore input. And I think if you just type regularly, add a space, input, and then as soon as you hit enter, it adds underscores in for you. Then we're going to change the label to photo input in a more user-friendly manner. And then we're going to come down to this integration attributes usage pane, click add item, and make sure it says diffuse because it's going to be a diffuse input. So we're going to leave that there for now. But while we're working, I'm going to add in a noise, just a random noise to use as a placeholder so that I can visualize what I'm doing while I work. So I'm going to hit spacebar and add a clouds to just any noise. It could be anything. And then I'm going to connect it to a gradient map because I need this input to be color. And a quick way to translate your grayscale values into color is just running it through a gradient map that is set to a color mode of color. Now, in your graph, let's add a histogram select node. And we're going to use this node to isolate a mask for our picture. So to do that, let's connect the output of our curve node into the input of our histogram select. And we're going to bring the contrast all the way up. Histogram select is a very useful node. Because the inside of our frame is a different grayscale value than the rest of our frame, we can isolate it with this node and generate our mask. So I'm going to double click histogram select, and I'm going to bring the range down and the position down. And you can see I'm starting to select that specific grayscale value. Now, if you're having trouble with this, you can try isolating your curve a little bit more. If you take these last 2 points and bring them up or down, you can then separate and define what grayscale value the inside of your frame is, and then go to your histogram select and find the range. Okay, so let's create a blend node, and let's hook up our gradient map to the foreground and our histogram select to the opacity input. And now you can see we're masking out this image. So let's connect this to our base color input. So I'm going to move this uniform color over here for now and connect this output from our blend into our base color. So now you can see just our cloud image inside our frame is showing off any kind of base color value. Next, I need to make a mask just for the frame itself. Let's create a histogram scan node. And I'm going to hook that up from our curve straight into the histogram scan. Let's bring the contrast all the way up again and find the position of just just our frame. So now I have a mask of just our frame. So it's really important to keep track of our masks because we're going to use these for our other outputs like metallic and roughness later on. So we've got our two masks here, and I've got this extra uniform color. I just want to fill in our frame with a color, so let's blend that in now. I'm going to add a blend, drag in our frame mask as our opacity mask for this blend, and then bring in the uniform color and blend in our clouds blend into the background. Then we'll just hook this up to our base color. And now you can see we have a frame with a color that we can choose and our image, but in this case right now it's our clouds. Things are going really well so far, but notice how when we scale our frame, our photo in the frame gets cropped. Now, it would be a lot more convenient if our utility substance could scale down this photo for us. We're going to do that by adding another parameter and function, building upon the process we just learned to create our frame size parameter. I'm going to reorganize the graph a little bit just so I can keep things clean. So I've got my base color stuff happening up here, and I've got my frame and things that are going on down here. Between our gradient map and our clouds noise and the blend node that we're using to mask it out in the center of the frame, between those two, I'm going to add a transformation 2D. Now, transform 2D has a special parameter called the transform matrix, and if we click on edit matrix values, you can see what I'm talking about here. The transform matrix is a combination of 4 values that are driving this transform widget. As we decrease the scale of our transformation widget, the x1 and y2 numbers increase. For later, let's think of these inputs as 1, 2, 3, 4. So 1 and 4 are changing. So I'm going to go into tiling mode. I'm going to click on this interesting looking icon here and choose absolute, and then change this to no tiling. So you can see we have our clouds here being transformed, no tiling occurring. Now, in order to see how small we can get this frame to be, let's double click on our graph to get back to our input parameters and bring our frame size all the way down to the bottom. So this is exactly how small we can make this in our particular graph. Then back in our transform 2D, we'll click edit matrix values again, and we'll dial in how small we can get this graph to be before we can see some of the clipping occurring. So because I need to increase to bring it down, I'm going to increase it to something like 3. You can see 3 by 3 is way too small, so let's just dial in a little bit more. Okay, 2.04 seems to be small enough here. Now because this is a square, I can type in 2.04 into here, and I know that it's going to match up perfectly. So we're going to remember and write down these variables for x1 and y2, which is 2.04. It's also important to know that the default value for x1 and y2 is not 0. It's actually 1. So if I type in 1 here, you see that it's going to fill up the frame. That's important to know for later on. However, y1 and x2, their default values are 0. So we want to control these two values, x1 and y2, with a single slider. So instead of exposing the values from the transform 2D, we're going to manually create an input parameter ourselves. If we go and double click on our graph to bring up our input parameters, click on the parameters tab, and find this little plus button with a circle in it. It says add a new input tweak. Click on that. You can see we have a new input here. Let's twiddle this down and change the identifier to photo size, and it's a float 1 and it's a slider. Let's change the label, photo size, and now that we have this parameter as a global float in our graph, let's double click on our transform 2D, and we can choose to edit the values if you'd like to. We're going to click on this graph and choose empty function. And so this should look a little bit familiar because it's exactly what we were doing when we were editing our frame size parameter. So first, let's start by getting all of our input variables and numbers into this function graph. So I'm going to hit spacebar and type in getFloat, and I'm going to choose our new photo size variable here. I'm also going to add just a normal float here and change that to 1 and add another float, and I'm going to keep it at 0. Finally, I'm going to add one more float, and this one's going to be our minimum value that we figured out in our transform 2D that we just wrote down. So I wrote mine down as 2.04. So let's change that. 2.04. You can see that the expected output type of this function graph is a float 4. To make a float 4, we need to do some conversions. Let's add a couple of nodes into the graph. First off, we're going to add one called vector float 4. And let's make a little bit of room down here so we can see what's going on. Next, I'm going to add a vector float 2. In fact, we need 2 of those, so I can just hit Control-C, Control-V, copy and paste. And now we have 2 vector float 2s and a vector float 4. We're going to connect these 2 vector float 2s into the inputs of our vector float 4. So we'll put this one in the top and this one in the bottom input. Remember when I said we had to think of our transform 2D's matrix inputs as 1, 2, 3, 4? Here's why. Going top down, we can think of these inputs as 1, 2, 3, and 4. We need to set 1 and 4 for our x1 and y2 matrix parameters. The other 2 will be set to 0. So let's get our float that we set to 0 and bring it over here, and let's set 2 and 3 to 0, because for those parameters, the default is 0. Now, we need to lerp between 1 and our minimum value. So, like before, let's add them now to each of our inputs. So I'm going to create a new lerp node here, and let's start organizing this a little bit. It's going to look a little bit complicated, but just follow along with me here. So for our first lerp here, that's going to go into this input. The smaller, or all the way to the left value of our lerp is going to be 2.04. Then the largest it's going to be is 1. And this is going to get driven by our photo size variable. Because remember, in the transformation matrix, numbers get bigger as it transforms and scales downward. So let's take the output of our first lerp and bring it into 1. Let's do the same exact thing for our number 4 input here. Now you can use the same lerp for the number 4 input as well, because the numbers are exactly the same, but I'm just doing it for practice. Create a new lerp. The smallest value is going to be 2.04, and it ramps up to the highest value, which is going to be 1, and it's going to be driven by our photo size input variable. We'll then apply this to the number 4 input of our matrix. Finally, because we need to set an output for our function graph, right-click on our vector float 4 and choose Set as Output Node. This is the most complicated part of the process, so take a look at your wires and make sure the connections look like mine. So let's test to see if our new function graph here works. So I'm going to go back to our main graph. I'm going to bring back our viewports here, double click on the background of our main graph, go to Preview, and scale photo size down. Perfect. You can see that our photo now resizes, and if I bring it all the way down, it only goes to the smallest value that we needed it to be. Same with if we increase our frame size, we can then scale our photo size all the way up to fill our frame. Our frame is almost done. Now, let's modify a couple of our map outputs to make the border of our frame a shiny metal and the picture a shiny glass. So we need to make a new mask. And now, in our little masks area here, let's create a new histogram scan node. And we'll hook it up again into from our curve output into our new histogram scan. Double click on the histogram scan, bring the contrast all the way up, and let's find the position where we have the entire frame, including our picture. So this is the full frame, and we now have a mask set up for that. We're going to define our roughness now. So we've got a uniform color hooked up to a roughness map already. Let's create a blend. And let's bring this uniform color into the foreground and then set this blend's output to our roughness. And then I'm going to Control-C, Control-V, make a copy of this uniform color, put it into the background. And then to set our opacity mask for this blend, we're going to use our new full frame histogram scan. So let's connect the output of that into the opacity input of our blend. So if I double click on this uniform color at the top and change its value and make it darker, you can see that we are now making our frame shinier. Next, we need to set up our metallic values. So here's our metallic output. And we only want our frame to have a metallic value. So luckily, we have a mask for that. And that's this one right here. This is the same one that we used to create the mask that we used to blend in our photo. Let's, between this uniform color and our metallic output, create another blend. And we'll hook the uniform color up to the foreground, remove it from the background there, so it's just connected to the foreground. And then use our frame only mask and adjust our uniform color value and increase it all the way to white. So now only our frame has a metallic value and not the photo inside it. And you can see a little bit more of the metallic if you change our uniform color that's driving our roughness and bring it down. You can see that we're getting a lot more of a metallic response here. We need to create an opacity output. So we'll hit spacebar, type in output, and we're going to change the components here. So we're going to add an item, and under usage, choose opacity. Then under the identifier, make sure it says opacity, and we'll change the label as well to make it more user-friendly. Then something that's really important here is right-click our graph and make sure we choose View Outputs in 3D View so that it then recognizes that this opacity output is being utilized. And you'll see everything disappears, but now what we need to do is drag in this full frame, including the picture mask, into our output. So now you can see we just have our frame being shown here with our new opacity map. Finally, there's one very important thing left to do, and that is to re-enable our photo input node. So all you need to do is take these two nodes, the clouds 2 and the gradient map, or whichever noise that you used, and just replace them with this photo input. Now you can choose to delete these if you want to, or you can keep them to see how it's working. Either one's good. Don't forget to save, and this is what our full graph looks like. To export this graph, go to your Explorer, right-click on the package, and choose publish.sbsar file. Then hit OK.
Great! I hope this video taught you a little bit more about functions and parameters in Substance Designer. There are so many parameters that you can expose to tweak and modify and customize all the substances you can create. I'd like to thank everyone who recently subscribed to this channel. You are awesome. And if you're new around here, welcome! I'm Jeremy Seiner, and I make videos on 3D content creation. If you're interested in more videos like this, subscribe to my channel and hit the bell to be notified when I post new videos. And if you like this video, hit the thumbs up. It lets me know you're watching and that you'd like to see more videos like this. That's it for now. I'll see you in the next one.